In this video, we're going to be solving one-step multiplication and division inequalities, and we are going to be using the same strategies again that we used with solving one-step addition and subtraction inequalities, just like we did with our equations. But we're going to find out that when we try to multiply and divide inequalities by negative numbers, we're going to run into a little bit of an issue. So our essential questions are, what happens when you multiply or divide inequalities by negative numbers, and how do you solve one-step multiplication and division inequalities? So first of all, the multiplication and division property of inequalities is very similar to the multiplication and division properties of equalities, with one small change. Here it says you can multiply or divide both sides of an inequality by a positive number and the inequality will still be true. Now that's key here. Now that's different than the multiplication and division properties of equality. There you could multiply by a positive or a negative, but here you can only multiply both sides of an inequality by a positive number and it will still be true. So a couple examples of that. Here I have an inequality that's obviously true. 12 is greater than 4, and I multiply both sides by a positive 3, and I get 36 and 12, and 36 is still greater than 12, so this inequality is still true. So if I multiply both sides of an inequality by a positive number, it will still be true. And then likewise, when I divide, I start with the same inequality. 12 is greater than 4, and I divided both sides by positive 2, divided both sides by a positive number, I get 6 is greater than 2, which is still true. So that part of the property still works. Now, what happens when you multiply or divide by a negative number? So here I start with the same inequality, 12 is greater than 4, but this time I multiply both sides by a negative 3. And when I multiply by a negative 3, a positive times a negative is a negative, so I get negative 36 and I get negative 12. And if I keep the inequality the same, greater than negative 36 is greater than negative 12, well, that is not true. Negative 36 is not greater than 12. And then likewise over here, 12 is greater than 4. And if I divide both sides by a negative number, I divided both sides by negative 2, I would get negative 6 is greater than negative 2. This is not true. Negative 6 is not greater than negative 2. It's further left on the number line. So what do we do when this happens? Are we just not allowed to divide both sides by a negative number? Well, we can, but we have to remember this little rule right here. If we reverse the inequality symbols, they will become true again. So I take the greater than symbol and flip it to the less than symbol. Now it's true. Negative 36 is less than negative 12. And if I take the greater than symbol here and flip it, negative 6 is less than negative 2. Now it's true, and that fixes the problem. So this is kind of something that we have to be aware of, and then we can fix that problem when it comes up. So here is the notes that you should have down. Whenever an inequality is multiplied or divided by a negative number, the inequality symbol must be flipped. Now you have to really pay attention here. It's not just when there's a negative number in the inequality. It's when you multiply or divide by a negative number. Those are the only two cases where you flip the inequality symbol. All the other cases, it will stay the same. Only those two cases, when you multiply by a negative or divide by a negative. So let's see if we can decide whether we should keep or flip. Should we keep the inequality symbol or should we flip it around? Here I have an inequality. 8 is greater than negative 5. And I multiply both sides by a positive 4. And I get 32 and negative 20. Should I keep the greater than symbol or should I flip the greater than symbol around? Well, I multiplied both sides of this inequality by a positive number, so I'm not going to flip the symbol around. It's going to stay greater than, and that is true. 32 is greater than negative 20, so I would keep in this case. Do not flip that inequality symbol around. A lot of students will see, well, there's a negative number here. I should flip it. No, that's not what I'm looking at. What I'm looking at is what I did to both sides of this inequality. I multiplied both sides by a positive number, so I'm going to keep it. Next, negative 18 is less than negative 12, which is true. And then I'm going to divide both sides by negative 6. So here I'm dividing both sides of this inequality by a negative 6, and I get 3 on the left-hand side and I get 2 on the right-hand side. Should I keep the inequality symbol less than or should I flip it to greater than? I should flip. This inequality symbol needs to be turned around because 3 is greater than 2. Okay, now it's true. So I had to change the inequality symbol to make it true because I divided both sides by a negative number. So whenever you multiply or divide by a negative number, that inequality symbol must be flipped. So keeping and flipping, that's an extra decision that we need to make. So how do we use these rules to solve one-step multiplication and division inequalities? Well, we're going to undo the multiplication or division using the properties of inequalities, but we have to remember that one extra thing. If in the process of solving the inequality, we multiply or divide by a negative number, you have to flip the symbol. Okay, so we're going to solve them just like we solved our equations, but we have to keep that one extra thing in the back of our mind. If we multiply or divide by a negative number, we have to flip the symbol. So here's a couple examples. 3x is greater than or equal to negative 18. This is multiplication that I'm going to undo. So I'm going to undo that multiplying by 3 by dividing by 3. So I divide both sides of my inequality by 3, and I get x on the left-hand side, and negative 18 divided by 3 is negative 6. And notice I did not flip. That was a keep because I divided both sides by a positive number. So I'm going to keep the inequality the same. So here's my solution. X is greater than or equal to negative 6. So then I graph my solution down here. Negative 6 is included, so that's a filled in circle, and it's greater than, so it's everything to the right. Okay, and then you can always check to make sure if you did keep or flip correctly by just choosing something that's shaded in here, like 0 should be a solution to this inequality. So I'm going to just check that. 3 times 0 is 0, and 0 is greater than or equal to negative 18. So I know I shaded the right way. So I know that I kept the symbol correctly. Next one, b divided by negative 4 is less than 7. So here I'm going to undo the division by multiplying both sides by negative 4. So you may have noticed, hey, I multiplied both sides by a negative number, and notice that the inequality symbol was flipped. I flipped it from less than to greater than because both sides were divided by a negative number, so I have to flip that symbol around. So b has to be greater than negative 28, and so here's negative 28 on the number line, and everything that is greater than negative 28. And I notice here on my number line that negative 20 should be a solution. So I'm just going to go ahead and plug that in there just to check to make sure that I shaded the right way. Negative 20 divided by negative 4 is positive 5. 5 is less than 7. So that works out. So I know that I shaded that the right way. It's real easy when you make your number lines just to pick a number that should make it true and test it just to see that you did everything correctly. So let's take a look at some here. And start from scratch. 6x is less than negative 48. So this is multiplication. So I need to undo my multiplication. So I'm going to use division. 6x divided by 6, and then negative 48 divided by 6. Divide both sides of this inequality by 6. 6x divided by 6 is x, and negative 48 divided by 6 is negative 8. Now, should I keep or should I flip? Well, look at what I did to both sides. I divided both sides by a positive 6. That's a positive number, so I'm going to keep. X is less than negative 8. That's my solution. So when I go to graph this, negative 8, negative 7, negative 6, negative 9, negative 10. X is less than negative 8. So negative 8 is not included, so that's an open circle, and it's everything to the left, which would be less than negative 8. And then again, I'm just going to pick a number over here that should be a solution. I'll pick negative 10. And if I plug that back in here, 6 times negative 10 is negative 60. Negative 60 is less than negative 48. That's true. So I know I did the right thing and I shaded the right way. Next, n divided by negative 2 is greater than negative 5. So I'm dividing by negative 2. So to undo that, I'm going to have to multiply both sides by negative 2. So n divided by negative 2 times negative 2, and then negative 5 times negative 2. And the left side is just n. Negative 5 times negative 2 is positive 10. Now the question, should I keep or should I flip? Well, if I look at what I did to both sides, I multiplied both sides of this inequality by a negative number. So what does that mean? I need to flip. So I look at my inequality symbol, and that needs to be flipped. That is now less than. N is less than 10 is my solution. So I'm going to go ahead and graph that. Here's 10, 11, 12, 9, 8. 10 is less than 10, so 10 is not included. Make that more clear. 10 is not included, and it's everything less than 10. So I'm going to shade to the left. So here's my solution. Now, 8 is a solution, or should be a solution, so I'm just going to plug that back in there. 8 divided by -2 is -4. -4 is greater than -5. That checks out. So I know, according to my graph, that my solution should be correct. So it doesn't take long to double check that using your graph, just to make sure you kept or flipped correctly. A couple more. -8b is greater than -24. This is multiplication, so to undo that, I'm going to divide. -8b divided by -8. -24 divided by -8. And this is just b. -24 divided by -8 is a +3. So now the decision, keep or flip. Is this going to stay greater than or equal to, or is it going to flip to less than or equal to? Well, again, if I look at what I did to both sides of this inequality, I divided both sides by a negative number. That is a flip scenario. So b is less than or equal to 3. So again, if I graph that, here's 3, 2, 1, 4, and 5. If b is less than or equal to 3, here 3 is included, so that's a filled in circle. 3 is a solution, and it's everything less than or equal to 3. So again, that's shaded to the left. And then again, I'm just going to pick a number that should be a solution. 1 is easy. So -8 times 1 is -8. -8 is greater than -24. So that checks out. So I know I shaded at least the right way there, so it seems my solution is correct. Last one, y divided by 7 is greater than -8. So this is division, so I'm going to multiply both sides by 7 to solve this. And this is y, and -8 times 7 is -56. Keep or flip. Again, look at what happened to both sides of this inequality. They were multiplied by a positive number, so this is a keep. Y is greater than -56. That's going to stay, so I'm going to graph that. Here's -56 on the number line, -55, -54, -57, -58, and y is greater than -56. So -56 is not included. That's an open circle. And then it's everything greater, so that's going to be shaded to the right. Now, none of these numbers that I have on my graph are divisible by 7, so that's kind of a pain. But I do know if I were to extend this number line and keep going to the right, eventually I'm going to get to 0. So 0 would be a solution, so I'm just going to use that because that's easy. 0 divided by 7 is 0. 0 is greater than -8, so that checks out. The right side of the number line is shaded in correctly. So quick ways to check those. Just pick easy numbers in your solution sets on those. Last one here, a real world example. Bags of candy are $3 each. You are allowed to spend at most $27 on candy. Write and solve an inequality that shows how many bags of candy you can buy. Well, here I'm looking at this first sentence. Bags of candy are $3 each, and the bags of candy is what's changing or unknown. So I'm going to call that B. B is going to be my number of bags of candy, and the cost would be 3 times B, since they're $3 each. You are allowed to spend at most $27. So that has to be less than or equal to 27. So there's my inequality. That's what that looks like. Now I'm just going to solve this. And this is multiplication, so I'm going to use division to solve this. 3b divided by 3 and 27 divided by 3. Divide both sides by 3. This is b, and 27 divided by 3 is 9. And since these are all positive numbers here, I'm not going to be doing any flipping. So b is less than or equal to 9. So that means the number of bags of candy that I can buy has to be less than or equal to 9. So I can buy at most 9 bags of candy. So solving inequalities involving multiplication and division, we have to remember that one special rule. Don't get tripped up by that. The only time we flip is when we multiply or divide by a negative number, not when there's a negative number present, but just when we multiply or divide by a negative number. And then please make sure you're graphing your solutions and checking those. It's an easy way to avoid those simple mistakes.